Now we can also have a quadratic equation and be able to work out a lot of different algebraic manipulations. So for example, we can be given, say, a quadratic equation x squared plus x minus 2 equal to 0, and we can be asked to say find 1 over alpha times 1 over beta. So the first step is to find the sum of the roots of this equation and the product. So we can have alpha plus beta. We know it's minus b over a. So this will be equal to minus of b, which is 1, over a, which is also 1. And this will be minus 1, and the product alpha beta, we know it's c over a, and this is going to be, our c is negative 2 and our a is 1, so we'll have minus 2. Okay, so the first thing is we can manipulate this and say 1 times 1, it's 1 over alpha times beta, it's alpha beta. So from the sum and the product, we'll only be able to use the product and plug it in there. So this will be 1 over alpha beta, which is negative 2, and this is just minus half. So this is the first approach. The second approach is trying to solve this very given quadratic equation and arrive at alpha and beta, which are the two solutions of this quadratic equation, and then just plug in here and there. So it's also another approach. So if we do that, we try to solve x squared plus x minus 2 is equal to 0. So if we factor, we're going to have product sum factors. So the product is negative 2, the sum is 1. Our factors, we have 1, 2, and we have negative there. If we multiply, we'll get negative 2. If we add, we'll get positive 1. And since the coefficient of x squared is 1, then we'll go directly and say this is x minus 1, x plus 2. And this will be equal to 0. So x will be 1 or minus 2. And therefore, our roots, we can say alpha is 1 and beta is negative 2. So from here, we can now just go directly and say we are trying to figure out 1 over alpha times 1 over beta. So we have 1 over alpha, we know it's 1, times 1 over beta, we know it's minus 2. So 1 over 1 is just 1. 1 times 1 half, well, 1 half, but we have a negative, which is just minus 1 over 2. So this is another approach of handling that question. But this approach sometimes can have limitations in cases where maybe the quadratic equation is complex to solve, or maybe it can take a lot of time, or maybe it has complex roots, so the other approach might be better. So we look at the next example. So here we have alpha plus beta as negative 1, alpha beta as negative 2. So we have alpha plus beta negative 1, alpha beta negative 2. So alpha plus beta negative 1, alpha beta negative 2. So we can actually use these two to manipulate almost everything that we can be given to solve. So we've dealt with 1 over alpha times 1 over beta. And what if we are given to find alpha squared beta cubed plus alpha cubed beta squared? So this is a plus, Okay, so here I can manipulate and say alpha squared is common and beta squared is also common. So on the first term, alpha squared is gone, but I'm remaining with 1 beta plus, I know 1 alpha is remaining and beta squared is already out. So this will be equal to this. I can write as alpha beta squared, and this is the same as alpha plus beta, since addition again is commutative. So this will be equal to alpha beta we have as -2, and then we are squaring it, times alpha plus beta, which is -1. So this will be equal to 4 times -1, which is -4. So that would be the solution to that. Then we can also have, say, alpha squared plus, say, beta squared. So from the first glance, we cannot do anything with this expression, but we can actually try to think outside the box. So we have a squared term on both sides. I can think of the expansion of alpha plus beta squared. So this expansion gives me alpha squared plus 2 alpha beta plus beta squared. Now from these, I can make alpha squared plus beta squared the subject and say alpha squared plus beta squared will be equal to alpha plus beta squared, and this 2 alpha beta will move to the other side and it will be minus 2 alpha beta. So this is an equivalent of that, and I know that alpha plus beta, I already have it. So alpha plus beta, I already have it here on top. It's -1. That is alpha plus beta, and alpha beta is -2, and alpha beta is -2. So from there I can say this will be equal to alpha plus beta is -1. I'm squaring that, minus 2 times alpha beta, which is -2, and this will be 1 plus 4, which will give me a 5. So further we can have, say, 1 over alpha minus 1 over beta. So now this is going to give us alpha beta, and then we have beta minus alpha. So that's what we'll have if we make this a single fraction. So there's no way we can know beta minus alpha from the first glance, but we can do some manipulation as well. So we can say, what if we are figuring out beta minus alpha squared? So beta minus alpha squared, this will be beta squared minus 2 alpha beta plus alpha squared. But my interest is beta minus alpha, so I can take the root and say beta minus alpha is equal to the square root of, I can say, alpha squared plus beta squared minus 2 alpha beta. Now, I don't know this, but from the previous example, we know alpha squared plus beta squared can be written as what we have here. Okay, alpha squared plus beta squared. So we have alpha plus beta squared minus 2 alpha beta. So we can say this is equal to alpha plus beta squared minus 2 alpha beta. Then we're saying this is minus 2 alpha beta. So from there we can now say this is equal to the square root of alpha plus beta squared minus 4 alpha beta. Now I have my expansion in terms of alpha plus beta and alpha beta. So just going back here, we can just now plug in. We know alpha plus beta is negative 1 and alpha beta is negative 2. So we have the square root of alpha plus beta, we know it's negative 1 squared minus 4 times alpha beta is negative 2. Now we just have to simplify. So this will be equal to the square root of 1 plus 4 times 2, that's 8. From here we'll have the square root of 9, and the answer is 3.